What if I told you that one simple question, what is everything really made of, launched the entire Western intellectual tradition? Tonight, we're tracing how ancient Greek thinkers moved from mythical explanations to rational inquiry, creating the foundation for science, philosophy, and how we understand reality itself. Dim the lights and take 2 slow breaths. We're about to meet minds that shaped how we think. Our knowledge of these early thinkers comes mostly from later authors and fragments, so we're piecing together human stories from scattered clues. From Thales declaring that everything is water to the shocking claim that reality might be completely different from what our senses tell us, these pre-Socratic philosophers wrestled with the deepest questions imaginable. We'll see how thinkers answered the same puzzle in opposite ways. Everything changes, or nothing ever does. The first person to offer a concrete answer lived in the bustling port city of Miletus around 600 BCE. Imagine walking through those Mediterranean streets, where merchants argue about grain prices while ships creak against wooden docks. The sun beats down on limestone buildings, and everywhere you look, water shapes the scene. It drips from the hulls of trading vessels, pools in the shade of market stalls, and flows through channels that keep the city alive. Among the crowds of traders and craftsmen, a quiet man named Thales watches this liquid world with unusual attention. He sees something others miss. For centuries, Greeks had explained the world through stories of gods and titans. Zeus hurled thunderbolts, Poseidon stirred the seas, and Gaia birthed the mountains. These tales satisfied most people, but Thales asked a different kind of question entirely. Instead of accepting that multiple divine beings shaped reality through their whims and conflicts, he wondered whether everything might spring from a single, natural source. What if the world had one fundamental ingredient, one basic substance that could explain all the complexity around him? His answer shocked everyone who heard it. Aristotle reports that Thales proposed water as the arche, the first naturalistic attempt to explain all diversity through one underlying principle. Not the tears of a sea goddess or the sweat of laboring titans, but ordinary water itself was the source of everything that existed. Imagine the reaction when Thales declared that the solid stone beneath their feet, the blazing fire in their hearths, the very air they breathed, all of it was ultimately water in different forms. To his contemporaries, this sounded like madness. How could something so common, so everyday, be the foundation of all reality? Yet Thales had observed something profound in his quiet watching. Water possessed an almost magical ability to transform itself. In winter, it became solid ice that could split rocks. In summer heat, it rose as invisible vapor that later fell as rain. This simple observation launched an entirely new way of thinking about the world. Rather than imagining competing gods with human personalities and conflicting desires, Thales proposed that reality followed natural patterns that human reason could understand. This insight marked a revolutionary break from mythological thinking. The world wasn't chaos held together by divine intervention, but a unified system operating according to discoverable principles. Water wasn't just an element among others. It was the element, the single substance that manifested as all the diversity they observed. The implications rippled far beyond philosophy. If everything was fundamentally water, then everything was connected in ways previous generations had never imagined. Thales was proposing something almost unthinkable, that human beings could use observation and reasoning to discover truth about the world without consulting priests or oracles. He wasn't claiming divine revelation or citing ancient authorities. He was simply pointing to what anyone could see and asking them to think carefully about what it meant. Water's transformations were visible to everyone, but Thales was the first to ask whether these changes revealed something fundamental about the nature of reality itself. The merchants in Miletus might have dismissed his theories as impractical speculation, but later writers remembered Thales as remarkably practical. Stories tell of him predicting weather patterns and even making money in olive presses. though these famous anecdotes come from much later testimony and may be legendary rather than historical fact. What matters is how these tales illustrate the new kind of confidence his approach created in human thinking. If natural phenomena could be understood through careful observation and reasoning, then perhaps other mysteries could yield to the same methods. This shift in thinking was subtle but profound. Rather than asking which god causes rain, people could now ask, what natural process produces rain? Rather than accepting that the world was too mysterious for human understanding, they could investigate whether apparent mysteries might have natural explanations. Thales had opened a door that could never quite be closed again. Of course, his water theory faced obvious challenges. How exactly did water become fire? What mechanism transformed liquid into solid rock? Thales had identified the question and proposed an answer, but the details remained unclear. His achievement wasn't providing a complete theory of everything, but demonstrating that such a theory might be possible. Standing in that ancient port, watching water in its endless transformations, Thales glimpsed something that would inspire generations of thinkers. He saw unity beneath apparent diversity, natural order beneath apparent chaos, and human capability to understand both. His bold proposal that water was the source of everything broke centuries of mythological thinking and opened an entirely new way of approaching reality. Yet even as his ideas spread, one of his own students began to wonder whether the master's answer raised more questions than it solved. Anaximander walked the same Mediterranean coastline where his teacher had watched water transform, but he carried a troubling question that kept him awake at night. If water truly is the source of everything, how can it give birth to fire, its own destroyer? How can wetness produce dryness, coolness generate heat? The logic that seemed so elegant in Thales' theory now revealed a fundamental flaw. Something wet cannot be the ultimate source of something dry without destroying itself in the process. Anaximander paced these familiar shores, but his mind wandered to places no human eye has seen. He envisioned something beyond the reach of sensation, beyond the categories that divide the world into hot and cold, wet and dry, light and dark. This source cannot be any particular thing, because any particular thing excludes its opposite. Water excludes fire, earth excludes air. But the true source must contain the potential for all opposites without being limited by any of them. He called this source the apeiron, a Greek word meaning boundless or indefinite. Imagine trying to grasp this concept in a world where everything has clear boundaries and definitions. The apeiron has no edges, no beginning or end in space or time. It contains all possible qualities without manifesting any single quality completely. Hot and cold exist within it as potential rather than actuality. Wet and dry wait in perfect balance for their moment to emerge into the world of appearances. This boundless source operates according to a cosmic justice that Anaximander sees playing out in the cycles of nature. He suggested a poetic, law-like process where opposites separate from the apeiron and left the details to imagination. Things emerge from the boundless when their time comes, enjoy their brief existence in the world of opposites, then return when cosmic balance demands it. Summer emerges and dominates for its allotted time, but cosmic justice requires that winter follow. Day rules for its proper span, but must yield to night. The seasons provide the clearest example of this cosmic justice at work. Winter emerges from the boundless, bringing cold and darkness to balance the heat and light of the previous summer. But winter cannot reign forever, because cosmic justice demands that it too must pay the penalty for its dominance. Each season emerges from the boundless, enjoys its time of dominance, then returns to make way for its successor. This vision extends beyond the weather to everything in existence. Plants emerge from the indefinite source, grow and flourish for their appointed time, then wither and return to the boundless. Animals are born, live their lives within the world of opposites, then die and dissolve back into the indefinite. Even human civilizations rise and fall according to this same cosmic justice. Understanding this cosmic order transformed how Anaximander saw the physical world itself. He became the first person to draw a map of the known world, showing how the Mediterranean connects different lands in a coherent pattern. He also proposed early evolutionary ideas, suggesting that humans originated from other animals. But his most startling insight concerned the Earth's position in space. Anaximander proposed that the Earth floats freely in the center of the cosmos, held in place not by Atlas or divine pillars, but by its equal distance from all directions. Imagine the courage required to suggest that solid ground beneath your feet is actually suspended in empty space. The Earth stays in position because cosmic justice prevents it from falling in any particular direction. It maintains its balance through the same principle of compensation that governs the seasons and the cycles of life and death. This floating Earth is shaped like a cylinder, with humans living on the flat top surface while the curved sides remain hidden. The sun, moon, and stars are actually holes in dark mist that surrounds bright fire, creating the illusion of moving lights in the sky. These celestial fires follow their own patterns of cosmic justice, appearing and disappearing according to the universal law of compensation that governs all existence. The implications of Anaximander's boundless source reach far beyond his teacher's water theory. If reality emerges from something indefinite and beyond sensation, then human knowledge must always remain incomplete. We can observe the world of opposites, trace the patterns of cosmic justice, and map the relationships between things, but the ultimate source remains forever beyond direct experience. This creates a new kind of humility in human thinking, recognizing that the deepest truths might always lie beyond the reach of our senses. Anaximander solved the logical problem his teacher couldn't address, but in doing so, he made reality even more mysterious. The source of everything cannot be experienced, touched, or directly known. It can only be inferred from the patterns we observe in the world of appearances. He offered comfort. Even apparent disorder obeys a deeper pattern, even if that pattern is ultimately mysterious. Yet his student would soon propose something far more tangible as the foundation of everything. Anaximenes found his answer in something as close as your next breath. Imagine air, not the empty space we think of today, but the very breath of life itself, dense enough to become stone, thin enough to become fire. Breathe in slowly and feel that invisible substance filling your lungs, carrying life to every part of your body. The third Milesian philosopher watched this same breath and saw something his predecessors had missed. Air wasn't just one element among many. It was the fundamental substance that could transform into everything else through the simple processes of thickening and thinning. Anaximenes faced the same challenge that had troubled Anaximander. How could one substance give birth to its opposite? How could something light produce something heavy? Something transparent create something solid? But where his teacher had retreated into the unknowable boundless, Anaximenes found a solution elegant in its simplicity. Air possessed a unique property that made transformation possible. It could compress and expand while remaining essentially itself. Later testimony from Theophrastus preserves Anaximenes' insight about the mechanism behind this transformation. When air compressed beyond its normal density, it first became visible as clouds drifting across the sky. Press those clouds further together, and they released their moisture as rain. Compress that water more intensely, and it solidified into earth. Force earth into even greater density, and it hardened into stone. Each step in this process was natural, observable, and mechanical. No divine intervention was required, no mysterious forces beyond human understanding. The transformation worked in the opposite direction as well. When air expanded and became thinner than its normal state, it grew hotter and brighter, eventually becoming fire. This explained why flames danced upward, seeking the thinner air above. Fire was simply air in its most rarefied state, naturally rising to find its proper place in the cosmic order. The sun itself was air expanded to its maximum thinness, burning with the intensity of ultimate rarefaction. This theory provided the first clear natural mechanism for change in the history of human thought. Previous philosophers had described what happened, but Anaximenes explained how it happened through purely physical processes. The mechanism was so simple that anyone could understand it, yet so comprehensive that it could account for every substance in the world. Wind was slightly compressed air, clouds were further compressed, water more compressed still, earth even denser, and stones the most compressed of all. Classical testimony linked this cosmic process to human life itself through the connection between breath and soul. Just as air holds our bodies together by flowing through our blood and carrying life to every part of us, air holds the entire universe together. Our individual breath is a small portion of the cosmic breath that animates all existence. When we die, our personal air returns to the vast reservoir of cosmic air, just as a drop of water returns to the ocean. This connection between human breath and cosmic air created a profound unity between the individual and the universe. Every time you breathe, you participate in the fundamental process that creates and sustains all reality. The air entering your lungs has been compressed into water, expanded into fire, condensed into earth, and rarefied back into air countless times throughout cosmic history. Your breath connects you to every stone, every flame, every cloud in existence. The theory explained not just the variety of substances, but their endless transformations. Summer heat rarefied the air, creating the fires of drought and the thin atmosphere of hot days. Winter compressed the air, bringing clouds, rain, and the dense atmosphere of cold weather. The seasons themselves were the breathing of the cosmos, expanding and contracting in eternal rhythm. Theophrastus recorded that Anaximenes explicitly stated how condensation and rarefaction naturally determine the particular characters of things produced from the originating air. Rarefied air becomes fire. Condensed progressively, it becomes wind, cloud, water, earth, and stones. Everything else emerges from these basic transformations through the same mechanical process. This mechanical understanding of transformation marked a crucial step in human thinking. For the first time, someone had explained natural change without appealing to mysterious forces or divine intervention. The process was purely physical, operating according to principles that human reason could grasp and predict. If you could understand how compression and rarefaction worked, you could understand how the entire cosmos operated. Yet even as Anaximenes provided this elegant material explanation for the physical world, other voices were beginning to question whether material processes could explain everything. The confidence in natural explanations that he helped establish would soon inspire thinkers to ask even more fundamental questions, not just about what the world was made of, but about the very nature of the gods themselves. Xenophanes carried a different kind of question as he wandered the dusty roads between Greek cities, his lyre in hand and observations that would challenge how people pictured gods. In markets and symposiums from Sicily to Ionia, he watched people worship deities who looked remarkably like themselves. Greek gods had Greek features, Ethiopian gods had Ethiopian features, and Thracian gods possessed the grey eyes and red hair of their worshippers. This pattern troubled Xenophanes deeply. He noticed that humans created deities who shared not just their physical appearance, but their emotions, desires, and moral failings. Zeus threw jealous tantrums, Hera plotted revenge against rivals, and Ares delighted in brutal warfare. These gods seemed less like cosmic powers and more like powerful humans with supernatural abilities. The more Xenophanes observed religious practices across different cultures, the more convinced he became that people were projecting their own nature onto the divine. His most shocking insight came in a simple observation that cut through centuries of religious assumption. If horses could draw, he declared, They would sketch their gods with flowing manes and powerful hooves. If cattle possessed artistic ability, their deities would have horns and udders. The implication was devastating. Human beings weren't discovering universal truths about divine nature through religious revelation. They were creating gods in their own image, attributing to these fabricated beings whatever qualities they admired or feared in themselves. This critique struck at the foundation of Greek religious life. Homer and Hesiod had shaped how Greeks imagined their gods for generations, describing divine beings who loved, hated, schemed, and fought like glorified aristocrats. Temple sculptures depicted gods with idealized human bodies. Religious festivals celebrated stories of divine adventures that mirrored human dramas on a cosmic scale. Xenophanes was suggesting that this entire religious world was human invention disguised as divine truth. But his challenge went beyond mere criticism. If the traditional gods were human projections, what was the divine actually like? Xenophanes proposed a single greatest god not like mortals in body or thought, representing an early rational theology that moved away from the competing deities of traditional mythology. This divine reality was one, eternal, and unchanging. It accomplished everything through the power of mind alone, without physical effort or emotional motivation. Unlike the quarreling gods of traditional mythology, this deity maintained perfect unity and consistency. It operated through thought rather than action, influence rather than intervention. Xenophanes extended this rational approach to natural phenomena that people traditionally explained through divine action. When sailors saw strange lights dancing around their ship's mast during storms, they attributed the phenomenon to divine twins called the Dioscuri. Xenophanes observed more carefully and concluded these lights were simply cloudlets interacting with atmospheric conditions. The rainbow wasn't the goddess Iris displaying her colorful pathway across the sky, but natural cloud formations creating optical effects. This rainbow example shows his consistent explanatory pattern. What people attributed to gods was really natural processes operating according to discoverable principles. These naturalistic explanations represented something revolutionary in human thinking. Instead of accepting traditional stories about divine intervention in natural events, Xenophanes encouraged people to observe carefully and seek natural causes. He was proposing that human reason and careful observation could penetrate mysteries that had always been relegated to religious explanation. Nature followed patterns that human intelligence could discover and understand. This approach required enormous intellectual courage. In a world where questioning the gods could bring charges of impiety, Xenophanes was suggesting that human beings possessed the ability to discover truth through their own efforts rather than through divine revelation. He wasn't claiming that gods didn't exist, but that humans could distinguish between genuine divine reality and cultural projections masquerading as religious truth. His epistemological humility balanced this intellectual confidence. While humans could make progress in understanding through observation and reasoning, complete certainty about ultimate questions remained beyond reach. He recognized the limits of human knowledge while maintaining faith in human capability to gradually approach truth through patient inquiry and critical thinking. The implications rippled through Greek intellectual life. If humans routinely mistook their own projections for divine revelation, what other assumptions might prove equally unfounded? If natural phenomena had natural rather than supernatural explanations, what did this mean for understanding reality itself? Xenophanes had opened questions that couldn't easily be closed. His critique of anthropomorphic religion established a new standard for thinking about ultimate questions. Claims about divine nature or cosmic truth needed to be examined rather than accepted on traditional authority. Human reason, while limited, possessed genuine power to distinguish between appearance and reality, between cultural assumption and universal truth. This questioning spirit would inspire thinkers who pushed rational inquiry even further. If traditional religious explanations proved inadequate, and if human reason could penetrate natural mysteries, perhaps reality itself operated according to principles far stranger than anyone had imagined. The courage to question the gods would soon inspire even more radical thinking about the fundamental nature of existence itself. In the mountain city of Ephesus, a mysterious figure known as the Dark One was developing an idea that would shake philosophy to its core. Imagine walking the narrow streets where merchants sold purple dye and silver coins, where the great temple of Artemis drew pilgrims from across the Mediterranean. Among these crowds moved Heraclitus, a man so fond of speaking in riddles that his contemporaries called him the Obscure. His book survives only in fragments, so our understanding of his thought requires careful interpretation of his famously aphoristic style. Heraclitus earned his reputation for obscurity through pronouncements that sounded like contradictions. He would say that the path up and down are one and the same, that the sea is the purest and the polluted water. People listening to these riddles often walked away frustrated, unable to grasp what this strange philosopher was trying to tell them. But Heraclitus wasn't being deliberately difficult. He was trying to express something about reality that ordinary language couldn't capture directly. His central insight would have horrified the Milesians who sought harmony and unity. Heraclitus declared that conflict and opposition, far from being problems to solve, were essential to existence itself. Without tension between opposites, nothing could exist at all. The string of a lyre produces beautiful music only because it maintains tension between opposing forces. If you remove that tension, the string goes slack and produces no sound. In the same way, reality itself depends on the tension between opposing principles. Consider his famous observation about rivers. You cannot step into the same river twice, he declared, because fresh waters are always flowing. Stand at the bank of any stream and watch the water pass. The river looks the same from moment to moment, maintaining its familiar shape and character. But the water that flows past your feet now is completely different from the water that flowed past a moment ago. The river maintains its identity precisely by constantly changing its substance. This paradox reveals something profound about the nature of identity itself. Things maintain their character not despite change, but because of it. Your body replaces every cell over the course of years, yet you remain recognizably yourself. A flame keeps its shape by constantly consuming new fuel and releasing waste products. Stability and change aren't opposites fighting each other, but partners in a cosmic dance that creates all the patterns we recognize as reality. Heraclitus made two fundamental claims that would echo through philosophy forever. First, everything flows, pantarei in Greek, meaning that constant change is the only permanent reality. Second, a unifying principle he called the logos governs this eternal flux, ensuring that all transformations follow rational patterns rather than random chaos. This cosmic logos operates through the eternal exchange between opposites. Hot and cold, wet and dry, war and peace don't simply replace each other randomly. They follow a divine reason that ensures cosmic justice through measured exchange. Winter gives way to summer in proper proportion. Conflict yields to harmony for exactly the right duration. Life emerges from death and returns to it according to cosmic law. The opposites depend on each other in ways that go beyond simple alternation. Hot has no meaning without cold to define it by contrast. Justice becomes valuable only where injustice threatens. Each opposite defines and creates its partner through their eternal tension. Heraclitus wasn't celebrating conflict for its own sake, but recognizing that the tension between opposing forces generates all the complexity and richness we experience as life. Heraclitus saw fire as the cosmic principle that governed this eternal dance of opposites. Fire embodies perfect change, eternally consuming and being reborn, maintaining balance through constant transformation. Unlike the static principles proposed by earlier philosophers, fire never rests, never achieves a final state of completion. It lives by consuming what feeds it, dies by running out of fuel, yet continues eternally as the process itself transcends any particular flame. This vision transformed how philosophers thought about unity and diversity. Previous thinkers had sought a single substance or principle that could explain apparent multiplicity. Heraclitus proposed that unity emerges from the eternal tension between opposites rather than from some underlying substance. The cosmos achieves harmony not by eliminating conflict, but by maintaining perfect balance between conflicting forces. His vision of eternal flux suggested something almost unthinkable to his contemporaries. Perhaps permanence is the illusion and transformation the truth. Perhaps what we take for solid, stable reality is actually a process so perfectly balanced that it creates the appearance of permanence while remaining in constant motion. Yet even as Heraclitus proclaimed that everything flows like a river, another voice was preparing to challenge this vision completely. In the Greek colonies of southern Italy, a poet-philosopher was receiving a vision that would deny change entirely. Picture Parmenides walking the quiet streets of Ilion, a small city where olive groves stretched toward the Mediterranean. Unlike the bustling ports where other philosophers gathered, Ilion offered the kind of silence that invites deep contemplation. Here, in this peaceful setting, Parmenides composed a poem that would challenge every assumption about reality that had come before. His poem begins with a mystical journey. Imagine a young man guided by divine horses along a cosmic pathway, racing through gates that separate night from day. The horses carry him beyond the familiar world of sense experience to meet a goddess who promises to reveal the deepest truths about existence. This isn't philosophy presented as logical argument, but as divine revelation received in a state of spiritual transport. The goddess speaks with authority that demands attention. She tells the young traveler that she will teach him two paths, the way of truth and the way of opinion. She warns that mortals have been following the wrong path entirely, trusting their senses and believing that what they see and touch reveals truth about reality. But the goddess reveals something shocking. Everything that appears to change, move, or transform contradicts the logical requirements of existence itself. Her revelation cuts deeper than anyone had imagined possible. If something truly is, it cannot begin or end. So true being must be timeless and unchanging. Think carefully about what existence means, she instructs. Something either exists or it doesn't exist. There can be no middle ground, no partial existence, no coming into being or passing away. If something truly exists, it must exist completely and eternally. This logical argument leads to conclusions that seem to contradict everything we experience. If what exists must be eternal, then nothing can come into being, because that would mean it previously didn't exist. Nothing can pass away, because that would mean it could stop existing. Nothing can move from one place to another, because movement requires empty space, and empty space is literally nothing, and nothing cannot exist. The goddess describes this true reality as a perfect sphere, complete and unchanging in every direction. It has no beginning and no end in time, no edges or boundaries in space. It is what Parmenides calls pure being, not the being of any particular thing, but being itself, the fundamental fact that anything exists at all. What is ungenerable and imperishable, a whole of a single kind, unshaking and complete. This creates a profound split between two different ways of understanding reality. The way of truth reveals that reality consists of a single, eternal, unchanging being. The way of opinion describes the world we think we inhabit, where things come and go, change and move, live and die. Parmenides invites us to treat sensory appearances as less reliable than reasoned argument, though he provided a practical account of appearances even while denying their ultimate reality. The way of truth shows that all multiplicity contradicts logical necessity. There aren't many different things, but only one thing that truly exists. All diversity, all change, all motion that we seem to observe are products of confused thinking. When we trust reason over sensation, we discover that reality is utterly unified and eternally at rest. In his account of appearances, Parmenides acknowledged that this apparent world follows certain patterns. He suggested that the moon receives its light from the sun and that the earth is spherical. But he insisted that this entire realm of opinion represents fundamental confusion about the nature of existence. Consider what this means for human knowledge. Everything you think you know through your senses, the warmth of sunlight, the flow of water, the growth of plants, the movement of animals, exists only as mistaken interpretation of an unchanging reality. Your senses present you with a world of constant transformation, but reason reveals that transformation is logically impossible. This isn't simply an academic disagreement about natural philosophy. Parmenides was claiming that the entire basis of human experience rests on confusion about the logical requirements of existence. The very idea that you are reading these words, that your eyes move across the page, that thoughts succeed one another in your mind, all of this apparent activity violates what reason demands about true being. The implications reach beyond philosophy into the foundations of knowledge itself. If reason and sensation contradict each other so completely, which one deserves our trust? Parmenides chose reason, accepting its conclusions even when they defied everything that seemed obvious through direct experience. This established a new standard for philosophical thinking that would influence Western thought for millennia. His vision presented the most radical challenge possible to common sense understanding. Not only were previous philosophers wrong about what reality was made of, they were wrong to think that reality contained multiple components at all. The goddess had revealed a truth so far removed from ordinary experience that it seemed almost impossible to believe. Yet the logical arguments supporting it appeared unassailable. How could anyone prove that something so perfectly reasoned was wrong? Someone would soon attempt to demonstrate these impossible-seeming claims through the contradictions that arise from denying them. Zeno of Elea stepped forward with mathematical weapons designed to defend his teacher's impossible vision. Picture Achilles, the swiftest of Greek heroes, racing against a tortoise, and losing, according to the strange logic of this brilliant mathematician. Greece's greatest warrior, capable of outrunning horses and chasing down enemies across battlefields, lined up beside a slow-moving reptile for what should be the most one-sided race in history. Yet Zeno insisted that this race would never end, that the swift-footed hero could never overtake his sluggish opponent. Zeno had dedicated his life to defending Parmenides' shocking claim that motion was impossible, while others dismissed his teacher as a dreamer lost in abstract speculation. Zeno approached the problem like a mathematician. He would prove through pure logic that anyone who believed in motion was trapped in contradiction. If he could show that motion led to absurd conclusions, then perhaps people would finally accept the vision of an unchanging, motionless reality. His Achilles paradox unfolds with devastating simplicity. Give the tortoise a head start, then watch what happens when the race begins. No matter how many halfway points Achilles crosses, there's always another. Zeno used this to show motion's paradoxical nature. The logic seems unbreakable. Achilles must cover an infinite series of distances, but he can never complete infinite steps in finite time. Mathematics had revealed something that common sense refused to accept. The swift cannot overtake the slow. But Zeno wasn't finished. He crafted another paradox that struck even closer to the heart of motion itself. Picture an arrow in flight, slicing through the air toward its target. An instant is motionless, so motion seems to dissolve into still moments. At any precise point in time with no duration, The arrow occupies a specific space equal to its own size. In that instant, it cannot be moving, because movement requires time, and an instant has no temporal extension. String these motionless instants together, and what do you get? More motionless instants. The arrow that appears to fly through the air is actually frozen at every point of its journey. His third paradox attacked the very foundations of spatial measurement. Imagine three equal groups of objects in a stadium. Place one group stationary in the center, while the other two groups move past it in opposite directions at equal speeds. This creates an impossible situation where the same amount of time allows one moving group to pass twice as many objects as the stationary group observes. Half the time equals the whole time, and half equals the whole. The mathematics of motion leads to logical contradiction. These paradoxes weren't clever puzzles designed for entertainment. They were serious philosophical weapons aimed at our most basic assumptions about reality. Zeno was demonstrating that trusting our senses leads to mathematical absurdities that reason cannot accept. If mathematics is reliable, then motion is impossible. If motion seems real, then mathematics fails to describe reality accurately. The implications reached far beyond abstract philosophy into practical questions about knowledge itself. Every day, people observed motion everywhere around them. Birds flew, rivers flowed, wheels turned, hearts beat. Yet careful mathematical analysis suggested that all these phenomena were either illusions or impossible contradictions. Which deserved more trust? The evidence of sensation or the conclusions of logical reasoning? Zeno had created a crisis in human understanding that couldn't be easily resolved. His paradoxes suggested that the world revealed through careful thought was completely different from the world experienced through direct sensation. The swift-footed Achilles remained frozen behind his tortoise opponent. The flying arrow hung suspended in mid-air, and time itself fractured into contradictory measurements. Mathematics had seemingly proven that motion was impossible, defending the most counterintuitive philosophical claim ever made. Later mathematics and philosophical work developed tools like convergent series, set theory, and calculus that treat Zeno's puzzles differently, offering intellectual resolution for later thinkers who could distinguish between mathematical infinity and physical processes. But in his own time, these logical challenges created genuine philosophical crisis about the relationship between mathematical reasoning and physical reality. Zeno forced philosophers to think carefully about time, space, and how we describe motion. His paradoxes revealed that even our most basic assumptions about reality might hide logical contradictions that careful analysis could expose. The questions he raised about the relationship between mathematics and the physical world would echo through centuries of philosophical inquiry. Yet even as some thinkers grappled with the impossibility of motion and change, others were beginning to discover that mathematics might offer a completely different path to understanding reality, not as a tool for creating logical puzzles, but as the very foundation from which the cosmos itself was built. In southern Italy, a mysterious community was discovering that reality itself might be made of numbers. Picture the coastal city of Croton around 530 BCE, where olive groves stretch toward the Mediterranean, and a strange brotherhood has gathered around a teacher from the island of Samos. Pythagoras and his followers live according to rules that seem almost monastic in their discipline. They bind themselves with sacred oaths, follow strict dietary practices, and organize their entire existence around a revolutionary insight about the mathematical structure of the universe. The Pythagoreans discovered something that changed how humans could think about reality itself. When they plucked a lyre string and listened to the pure tone it produced, then pressed that same string exactly halfway along its length, the resulting note sounded precisely one octave higher, a perfect 2-to-1 ratio. Press the string at 2/3 its length, and they heard the fifth in a 3-to-2 ratio. For listeners, this means Pythagoreans found harmony in numbers, not just in music. These weren't approximate relationships or cultural preferences. They were exact mathematical proportions that governed the most beautiful sounds human ears could perceive. This discovery shattered the assumption that mathematics was merely a practical tool for measuring grain or calculating distances. Numbers weren't just human inventions for keeping track of quantities. They were the fundamental language in which reality expressed itself. The harmony that made music beautiful emerged from precise numerical relationships embedded in the very structure of sound itself. Mathematics had revealed itself as the hidden architecture of beauty. The Brotherhood extended this insight with breathtaking audacity. If numbers governed musical harmony, perhaps they governed everything else as well. They observed the regular movements of planets across the night sky, and proposed that these celestial bodies produced their own music as they traveled their ordained paths. The faster-moving planets generated higher tones, the slower ones deeper notes, creating a cosmic symphony that filled the universe with mathematical harmony. They called this the music of the spheres, a celestial concert playing continuously just beyond the range of human hearing. This wasn't mere poetic metaphor. The Pythagoreans believed they had discovered the literal truth about how the cosmos operated. Numbers and ratios controlled not just the sounds of earthly lyres, but the movements of sun, moon, and stars. The same mathematical principles that created harmony in music created order in the heavens. Reality itself was constructed according to numerical patterns that human reason could discover and understand. Their vision extended even deeper into the nature of human existence. The Pythagoreans taught that individual souls participated in this cosmic mathematical harmony. Each person's soul was immortal and would travel through different incarnations, gradually purifying itself through successive lives until it achieved perfect understanding of numerical truth. This doctrine of transmigration wasn't simply about reward and punishment in future lives. It was about the soul's progressive education in mathematical reality. The Brotherhood divided into two groups reflecting different approaches to this cosmic truth. The Anaximander followed Pythagorean precepts and practices, living according to the moral implications of mathematical harmony. The Mathematicians pursued the more theoretical aspects of numerical philosophy, seeking to understand how mathematical relationships created and sustained reality. Both groups shared the conviction that proper understanding of numbers could transform human life and align it with cosmic order. This connection between mathematical knowledge and moral purity created a unique way of life. The Pythagoreans practiced vegetarianism, believing that eating meat disrupted the mathematical harmony of the soul. They valued friendship above all other human relationships, seeing it as a reflection of numerical proportion and balance. Their entire community was structured around achieving the kind of harmony they observed in musical ratios and celestial movements. Many specific doctrines later attributed to Pythagoras himself, including the famous theorem that bears his name, likely developed over time as the movement blended mystical practices with mathematical inquiry. What matters is how this community recognized that mathematics could be more than just a tool for solving practical problems. It could be the fundamental language in which the universe expressed its deepest truths. Numbers weren't abstractions invented by human minds, but discoveries about the actual structure of existence. This mathematical mysticism would profoundly influence later thinkers, particularly Plato, who adopted their emphasis on mathematics in explaining natural phenomena and their belief in the immortality of the human soul. The Pythagoreans had glimpsed something profound about the relationship between human reason and cosmic order, suggesting that careful mathematical thinking could reveal truths about the nature of existence itself. Their discovery that numbers and mathematical ratios governed everything from planetary motions to musical harmony opened a new chapter in humanity's attempt to understand reality. Yet the fundamental tension between change and permanence that had troubled earlier philosophers remained unresolved, waiting for someone to propose an entirely different approach to this ancient puzzle. Empedocles found a different path entirely. Picture the volcanic slopes of Mount Etna in Sicily, where sulfur springs bubble from the earth and the air carries the scent of wild thyme. Here lived a remarkable figure who combined the roles of poet, physician, and philosopher in ways that would have seemed impossible to earlier thinkers. Empedocles walked among the Greek colonies of southern Italy as both healer and mystic, wearing purple robes and bronze sandals, claiming powers that bordered on the divine. This extraordinary man faced the greatest puzzle in early philosophy. Parmenides had proven through logic that change was impossible, yet everyone could see that change happened constantly. Plants grew and withered, seasons turned from hot to cold, living creatures were born and died. How could both the logical argument and obvious experience be true? Previous philosophers had chosen sides, but Empedocles refused to accept that human reason and sensory evidence had to contradict each other. His solution emerged from careful observation of the natural world around his volcanic homeland. Earth, air, fire, and water appeared everywhere in different combinations, but these basic elements themselves never seemed to change their essential nature. Fire remained fire whether it burned in a hearth or blazed from Etna's crater. Water stayed water whether it fell as rain or flowed in mountain streams. The elements were eternal and unchanging, just as Parmenides demanded, but they could mix and separate in countless ways, creating all the variety that experience revealed. Empedocles wrote his insights in verse, weaving together cosmological theory with ethical practice in ways that showed how understanding the universe connected directly to living properly within it. Imagine a painter's palette where red, blue, yellow, and white pigments remain distinct colors, but their combinations create every hue visible in a finished artwork. Empedocles proposed that reality operated the same way. The four elements served as cosmic pigments that never changed their individual character, but produced infinite variety through their mixing. A flower contained all four elements in one proportion, a rock contained them in another, and a human being represented yet another unique combination of the eternal quartet. But what caused these elements to combine and separate? Empedocles introduced two cosmic forces that operated like opposite magnetic fields throughout the universe. Love drew the elements together, creating harmony and unity wherever it dominated. Under love's influence, earth mixed gently with water, air blended smoothly with fire, and complex forms like plants, animals, and human beings could emerge from the marriage of different elements. Strife worked in the opposite direction, driving the elements apart and preventing their union. When strife gained power, it pulled earth away from water, separated air from fire, and broke down the complex combinations that love had created. These weren't moral categories of good and evil, but natural forces as inevitable as gravity or magnetism. Neither love nor strife could be eliminated from the cosmos, because both were necessary for the eternal cycle of creation and destruction. Empedocles envisioned cosmic history as an endless rhythm between these opposing forces. Picture ages when love dominated completely, gathering all four elements into a perfect, harmonious sphere where no individual things existed. This cosmic unity represented absolute peace, but also absolute stagnation. No plants grew, no animals moved, no thoughts occurred, because love had eliminated all the separation necessary for distinct beings to emerge. As strife gradually gained influence, cracks appeared in this perfect unity. The elements began to separate, creating the first opportunities for individual things to form. During periods when love and strife balanced each other, the world we know could exist, complex enough for life and thought, but stable enough to maintain recognizable forms over time. When strife reached its maximum power, complete separation would tear everything apart, leaving only isolated elements floating in cosmic loneliness. This cyclical vision explained both permanence and change without contradicting either. The four elements provided the permanence that logic demanded. They never changed their essential nature or came into existence from nothing. The forces of love and strife provided the change that experience revealed. Constant mixing and separation that created all the diversity we observe. Birth wasn't the creation of something from nothing, but new combinations of eternal elements. Death wasn't passage into nothingness, but the separation of elements that would recombine in different forms. Empedocles combined his cosmic vision with practical ethics, advocating vegetarianism and belief in transmigration of souls as natural consequences of understanding how all things shared the same elemental nature. Scholars now see his cosmic and ethical visions as deeply intertwined, particularly after recent papyrus finds have enriched our understanding of his integrated approach to philosophy and life. As both physician and philosopher, Empedocles understood that theoretical knowledge needed practical application. He used his four-element theory to explain health and disease as conditions of proper or improper elemental balance within the human body. His medical practice grew directly from his cosmic vision, demonstrating how understanding universal principles could guide specific interventions in individual cases. Yet even this elegant solution raised new questions. If eternal elements mixed and separated according to cosmic forces, what determined the timing and direction of these changes? Perhaps the universe needed something more than mechanical forces to explain its intricate organization. Anaxagoras arrived in Athens carrying an answer that would change everything. Picture the bustling agora where philosophers gathered beneath the shadow of the Acropolis, debating questions that had puzzled thinkers for generations. Among these voices walked a man from the distant city of Clazomenae, who brought ideas so revolutionary they would eventually lead to charges of impiety against the gods themselves. Anaxagoras looked at the organized world around him and asked a question that had never occurred to his predecessors. How did order emerge from chaos? Earlier philosophers had proposed elements like water or fire, cosmic forces like love and strife, but none had explained what actually initiated the process of cosmic organization. What set everything in motion? What determined why things developed as they did, rather than remaining in primordial confusion? His answer introduced something unprecedented into Greek philosophy. Mind, which he called nous, existed as a separate principle from all material substances. This wasn't the human mind writ large, but a cosmic intelligence that possessed the power to know all things and set the universe in motion. Unlike the anthropomorphic gods of traditional mythology, nous operated through pure intelligence rather than emotion or physical force. But Anaxagoras proposed something even stranger about the material world that mind organized. Everything contained seeds of everything else, he claimed. In your bread, there were tiny portions of hair, bone, flesh, and every other substance that existed. In your hair, there were microscopic seeds of bread, stone, water, and gold. This wasn't a poetic metaphor, but a literal description of how reality was constructed. Every object was an infinite mixture of all possible substances. Imagine trying to make sense of this bizarre theory. How could bread contain hair, or hair contain bread? Anaxagoras explained that each thing appeared to be what it was because one type of seed dominated the mixture, not because it was pure. Bread looked and tasted like bread because bread seeds outnumbered all other seeds in that particular combination. But the other seeds remained present, invisible to our senses, but real nonetheless. This infinite mixing created a problem that only intelligence could solve. Originally, all things were together in complete chaos, with no separation between hot and cold, wet and dry, light and dark. Left to itself, this mixture would remain forever confused, with no recognizable objects ever emerging. Only a cosmic intelligence could begin the process of sorting, separating, and organizing that would create the structured world we observe. Mind initiated rotary motion, spinning the original mixture and beginning the long process of separation. As this cosmic rotation continued, similar seeds began to cluster together. Hot seeds gathered with other hot seeds, wet with wet, dense with dense. Gradually, distinct regions emerged where different types of seeds dominated, allowing recognizable substances and objects to form. The process wasn't random or arbitrary. Mind knew all things and guided the separation according to its perfect intelligence. It determined which seeds would cluster where, how fast the rotation would proceed, and what patterns would emerge from the cosmic sorting. This wasn't mechanical necessity like Empedocles' love and strife, but intelligent design operating according to rational principles. Anaxagoras extended this naturalistic approach to phenomena that Greeks traditionally explained through divine intervention. The sun wasn't the god Helios driving his chariot across the sky, but a fiery stone larger than the entire Peloponnese. The moon didn't shine with its own divine light, but reflected illumination from the sun. Eclipses occurred when celestial bodies cast shadows on each other, not when gods expressed anger or warning. His naturalistic account of celestial bodies was controversial in Athens. When Anaxagoras declared that the sun was a stone, he was offering explanations that bypassed traditional religious understanding entirely. When he explained rainbows through natural cloud formations rather than divine messages, he was removing the gods from direct involvement in natural phenomena that most Athenians considered sacred. The political implications became unavoidable. Athens was fighting for its survival against Sparta, and traditional religion played a crucial role in maintaining civic unity and divine protection. The charges of impiety that eventually threatened him weren't merely academic disagreements about natural philosophy. Pericles defended and assisted him during these troubles, but the tensions reflected deeper questions about whether human reason could replace divine authority as a source of truth about the world. His concept of cosmic mind influenced later philosophers who struggled with similar questions about intelligence and natural order. Though separated from matter, mind could act upon it to create organization and pattern. This suggested that intelligence might be a fundamental feature of reality, rather than a late development in cosmic history. Anaxagoras had introduced mind as the principle that sets matter in motion and creates cosmic organization. Yet even this cosmic intelligence, operating on infinite mixtures of seeds, seemed complex compared to what some thinkers were beginning to imagine. Perhaps reality required something far simpler than anyone had dared to propose. Two thinkers from the northern Aegean colony of Abdera proposed the most elegant solution yet imagined. Picture those sandy shores where merchant ships brought news from across the Mediterranean, and where Leucippus and his student Democritus developed an idea so radical it seemed almost impossible to their contemporaries. Everything that existed, they claimed, was made of tiny, indivisible particles moving through empty space. They called these particles atoms, from the Greek word meaning uncuttable. Between these atoms lay void, absolute emptiness that allowed the atoms to move and rearrange themselves in countless combinations. The genius of atomic theory lay in how it solved the greatest puzzle that had tormented earlier philosophers. Parmenides had proven through logic that true being must be eternal and unchanging, while everyone could see that change happened constantly throughout the natural world. Democritus showed how both could be true simultaneously. The atoms themselves were eternal and indivisible, differing in shape, arrangement, and sometimes weight, exactly as Parmenides demanded. But these unchanging atoms could rearrange themselves in infinite patterns, creating all the variety and transformation that experience revealed. Imagine reality as an endless dance of invisible particles. Each atom possessed a particular shape, some round, some angular, some smooth, some rough, some large within atomic scale, some smaller. These shapes determined how atoms could connect with each other. Round atoms rolled freely and created smooth textures, while rough atoms caught on each other and formed harder substances. Angular atoms locked together in rigid patterns, creating solid materials, while smoother atoms flowed past each other easily, forming liquids and gases. The combinations were limitless. Different arrangements of the same basic atoms could produce substances as different as honey and stone, flesh and bone, water and fire. Sweet taste resulted from round, smooth atoms that rolled gently across the tongue. Bitter taste came from sharp, jagged atoms that scratched the mouth's sensitive surfaces. Hot and cold, wet and dry, hard and soft. All these qualities emerged from specific atomic shapes and arrangements rather than fundamental differences in substance. Democritus extended this insight to human sensation itself. The atoms that made up our eyes, ears, and tongues could only detect certain atomic patterns. This led to his famous observation that captures the heart of atomic theory. By convention sweet, by convention bitter, by convention hot and cold, but in reality only atoms and void. Colors weren't inherent properties of objects, but results of particular atomic structures interacting with the atoms that formed our vision. Sounds weren't carried by gods or spirits, but by streams of atoms traveling through the air and striking our ears. Even thoughts and emotions were movements of especially fine, fast-moving atoms that composed the human soul. This created a profound distinction between appearance and reality. Our senses showed us a world of colors, tastes, sounds, and smells, but reason revealed that these were merely conventional descriptions of atomic interactions. The real world consisted only of atoms and void, moving according to natural necessity without purpose or divine intervention. The implications reached beyond natural philosophy into the deepest questions about human existence. If souls were made of atoms, then consciousness itself was a natural phenomenon rather than divine gift. When people died, their soul atoms scattered and rejoined the cosmic dance, just like the atoms that had formed their bodies. There was no judgment after death, no eternal punishment or reward, because there was no surviving self to experience either. They saw natural events as necessary outcomes of atomic motion, a view later thinkers wrestled with extensively. Every atomic collision followed natural laws without exception. Nothing happened by chance or divine intervention, because every event resulted necessarily from the previous arrangement of atoms in motion. The future was already determined by the present configuration of atomic positions and velocities, even though humans lacked the knowledge to predict specific outcomes. Yet this determinism didn't create despair, but liberation. If everything happened by necessity, then anxiety about the future became pointless. Death lost its terror when understood as simple atomic dissolution. The ancient atomists weren't simple atheists. They minimized the god's role in natural processes, but didn't necessarily deny all divinity. Humans were free to pursue happiness and knowledge without fear of supernatural punishment or favor. Democritus had created the most comprehensive explanation yet proposed for both the unity and diversity of nature. Everything shared the same atomic foundation, creating fundamental unity. But infinite possible arrangements of these atoms explained all the rich variety that experience revealed. Birth and death, growth and decay, mixture and separation, all became natural processes of atomic rearrangement rather than mysterious supernatural events. The atomic theory represented the ultimate confidence in human reason over traditional authority. Without divine revelation or ancestral wisdom, using only careful observation and logical thinking, Democritus had constructed a complete picture of reality that explained everything from planetary motion to human emotion. Yet as these grand theories multiplied, each claiming to reveal the true nature of everything, some thinkers began to wonder whether the real problem lay elsewhere entirely. Professional teachers arrived in Athens with a radically different approach to these ancient questions. Picture the city in the middle of the 5th century BCE, where democracy has created something unprecedented in human history. Citizens gather in the agora to debate policy, juries of hundreds decide legal cases, and political careers rise or fall based on the power of spoken argument. In this world where persuasion determines success, a new kind of educator has emerged, the Sophists. These traveling teachers offered something that previous philosophers had never considered: practical instruction in the art of argument itself. While Thales pondered water and Democritus contemplated atoms, the Sophists asked whether any of these cosmic theories actually mattered for human life. They turned their attention away from the distant questions of what reality was made of and focused, instead, on the immediate question of how humans could navigate the world they actually inhabited. The Sophists weren't seeking universal truths about the nature of existence. They were offering skills that could help their students succeed in democratic Athens, where the ability to speak persuasively in the assembly or law courts could determine everything from personal wealth to political power. They taught rhetoric, the systematic study of how language could be used to influence others, regardless of whether the arguments being made were objectively true or false. Pythagoras of Abdera, the most famous of these new teachers, made a claim that would have shocked every previous philosopher. "Man is the measure of all things," he declared, "of the things that they are, and of the things that are not that they are not." This statement can be read as epistemic relativism, suggesting that knowledge is relative to individual human perception, or as a claim about human-centered knowledge more broadly, whether species relative or individual relative. Either interpretation challenged the assumption that truth existed independently of human judgment. Consider what this meant for all the grand theories that had come before. Thales believed water was the fundamental principle, but Anaximenes argued for air, while Democritus insisted on atoms. According to Pythagoras, all of them could be right simultaneously. If Thales found the water theory convincing and useful, then it was true for Thales. If Democritus discovered atoms more satisfying, then atoms were real for Democritus. Truth wasn't a single, objective reality waiting to be discovered, but a relationship between individual minds and their particular experiences. This relativistic perspective extended beyond natural philosophy into every area of human concern. Religious beliefs, moral values, political systems, all of these reflected human conventions rather than universal principles carved into the structure of reality itself. Pythagoras expressed this uncertainty clearly regarding the gods. "Concerning the gods, I cannot ascertain whether they exist or whether they do not, or what form they have, for there are many obstacles to knowing, including the obscurity of the question and the brevity of human life." Gorgias of Leontini pushed skepticism to an extreme, arguing that nothing could be both asserted and communicated with certainty. In his systematic challenge, he proposed that nothing exists, and even if something did exist, it could not be known, and even if it could be known, it could not be communicated. This wasn't merely doubt about specific theories, but a complete challenge to the possibility of knowledge and communication themselves. The Sophists revealed a fundamental tension that previous philosophers had ignored. They distinguished between nature and convention, asking whether the customs, laws, and beliefs that govern human societies reflected natural principles or merely arbitrary human agreements. If moral rules were natural, they should be the same everywhere. But careful observation showed that different cultures followed completely different moral codes with equal conviction. This insight had practical implications for anyone living in a diverse, cosmopolitan city like Athens. Merchants arriving from Egypt brought different religious practices, ambassadors from Persia operated according to different political assumptions, and even neighboring Greek cities maintained conflicting legal systems. Which set of conventions reflected natural truth? The Sophists suggested that none of them did, because all human institutions were conventional rather than natural. Their skepticism about universal truth led to sophisticated techniques of argument that could make any position seem reasonable. They developed methods for arguing both sides of any question with equal skill, demonstrating that persuasive reasoning could support contradictory conclusions. This wasn't intellectual dishonesty, but recognition that human knowledge might have fundamental limits that made absolute certainty impossible. These professional teachers understood something that earlier philosophers had missed: the practical power of questioning established assumptions. In a democratic society where citizens needed to evaluate competing proposals and judge between conflicting testimonies, the ability to recognize weak reasoning and identify hidden assumptions provided genuine advantages. Plato painted them badly in his dialogues, but modern scholarship sees a diversity among sophists, many of whom contributed significantly to rhetoric, law, and civic life. Their questions about the relationship between knowledge and reality created tensions that would inspire entirely new approaches to these ancient problems. The confidence that human reason could discover cosmic truth, the very foundation that had supported 2 centuries of philosophical inquiry, now faced its most serious challenge yet. The Sophists had shattered something precious, but they also revealed something profound about human inquiry itself. As you drift toward sleep tonight, consider this. That simple question about what everything is made of opened a conversation that continues in ways these ancient minds could never have imagined. Their questions still echo in modern physics and philosophy. Our methods differ, but the same restless curiosity remains. These ancient thinkers gave us the tools we still use, the confidence that nature follows patterns we can discover, the courage to question what everyone believes, and the wisdom to keep asking even when answers seem impossible. Breathe slowly, let your eyelids feel heavy, and if you'd like, share where you're tuning in from in the comments below. Sweet dreams, and remember, every time you wonder about the nature of reality, you're joining a conversation that began with Thales watching water 26 centuries ago. What we know of these remarkable minds comes mostly from fragments and later reports, but their questions remain as alive today as they were in those ancient Mediterranean cities. If you're still awake, be sure to like and subscribe for more great thought to ponder you into restful oblivion.